Application questions. We'll take them as examples. Applications of binomial. 1. Find find A, B, and C in the expansion of 1 plus 2y power 7 is equal to 1 plus ax, 1 plus ay plus by squared plus cy power 3. Solution. At least now life is becoming easy. 1 plus 2y power 7. This will be the same as 1 plus 7 our n multiplied by 2y plus 7 minus 1 over 2 multiplied by 2y squared plus 7 minus 1 7 minus 2 over 3 factorial is 3 times 2 2y power 3. Once I reach power 3, I stop. This is the same as 1 plus 14y plus 7 by 6 over 2 multiplied by 4 y squared. Where is 4 coming from? There's a 2 inside the brackets there. So 2 squared is 4. Plus 7 minus 1, 6. 7 minus 2, 5 over 6. Where is 6 coming from? 3 times 2 is 6. This 3 times 2 down here is 6. Then 2 power 3, 8. Y power 3. Where is 8 coming from? There's a 2 in the brackets. To the power 3, so it will be 8. Then 2 here, 1.
Sir.
2 there, 2. Hello. Ask.
There why you have written 7 to y. Isn't 1 to the power 7 which gives it 1? Why remaining just is 2y then?
1 plus ax power n is 1 plus n ax plus n minus 1 over 2 ax squared plus n minus 1 n minus 2 over 3 factorial ax squared. So our n in that question, our n is 7, our a is 2 in this substitution.
Oh, so I understand.
Okay.
I thought we're using that one for n choose 1. Yeah, that one.
Okay. So that now we have 6 here, 1, 6 there, 1. So now we calculate 2 times 6, 12. 12 times 7, 12 times 7, 4 here, 84. So we have 1 plus 14y plus 84y squared plus 7 times 5, 35. 5 times 8. 8 times 5, 40. 24. 24, 28. So plus 280 y power 3. That's it. For this one.
So how do you know that here you use n choose 1, n choose 2, then you use 1.
In fact,
You use
we
n choose, n
in fact
choose 0.
we only use n choose 1, n choose 0, n choose 1 when we are dealing with identities. Anything else we use the already calculated n choose 0, n choose 1, n choose 2. So look at this question. Find.
So can I see your previous board?
Okay. Find the first 3 terms in the expansion of.
We are done with that example.
Yes.
What are the values of A and B?
In the expansion of. Okay, just a minute. Find the first 3 terms in the expansion of 1 over x minus x squared power 12. This example, A is 14, B is 84, C is 280.
Sir,
Hello. That's how this question ends.
Sir, change the board. Here you've said n is equal to 7 and a is equal to 2. Where is that 2 coming from?
No, I mean, we meant in this question. This question compared to this expansion.
Oh, okay.
Sir,
So,
is
sir,
it okay to leave it as 7 times 5 times 8 as C to be equal to 7 times 5 times 8? Can I earn a mark?
To avoid getting 280. No, 280 is too small.
Can I earn a mark, sir?
No, ending a mark is a must, but the question is, can I lose the marks if the marks had to be 3? It's possible, yeah, that you can lose it.
sir,
Hello.
I think for B, it's not supposed to be 84.
Yeah, you're right. It's supposed to be
168, that's what I found.
I think it's supposed to be 84. Calculate again.
Sir,
Yes, it's supposed to be 84.
isn't it not supposed to be?
Because 7 times 6 is 42, isn't it? Then 42 by 2 is 84.
And then 84, you multiply by that 2, since the y has a 2 squared.
Now
The
there's also
denominator
a 2.
as a 2.
Yes.
Which divides the 168 by 2 for you to get back to 84.
Sir,
So what you have is 7 by 6 by the 2y squared, is it?
and
Now
then
the-
over the 2 now.
Now over the 2. Now the 7 by 6 is 42. 42 by 4 over 2. You are getting 168 over 2 y squared. But this is 84. Do you agree?
Let me check.
All right. Okay.
Oh, yeah.
So I know that you accept, that you agree. So when do we use, is it a must that is it that we should never use n choose 0, n choose 1 in such questions? Question is, yes. So the thing is going to be, look, even if I bring n choose what n, if I use n choose 0, I must start calculating what is 12 choose 0, what is 12 choose 1, what is 12 choose 2. I may waste a lot of time. So I will use the already known expansion 1 over x, which is my a, to the power 12, which is n, plus n 1 over x. This is a, 12 minus 1 negative x squared plus 12 minus 1 over 2, 1 over x, 12 minus 2, negative x squared, so that we get 1 over x power 12 plus 12 over x power 11. On top, there's a negative x squared plus 12, 11 over 2. And then we have x power 4 over x power 10. So that we have 1 over x power 12 minus 12 over x power 9 plus 2 here, 1, 2 there, 6. 6 by 11 is 66 over x power 6. You have the first 3 terms there. Now, if somebody decided to use the n to 0, so you have 12 to 0, 1 over x power 12. You have 12 choose 1, 1 over x, 12 minus 1, negative x squared, 12 choose 2, 1 over x, 12 minus 2, negative x squared. Before they move to this step here, the first thing will be calculating 12 choose 0, calculating 12 choose 1, calculating 12, choose 2. And then when they get these numbers, that's when you come to this step. And then this step. So you can see that the area one is shorter. And then that's why I don't like the choose thing.
All right, thank you.
Okay. 3, by substituting.
So I'm kindly asking if you can return back to the previous board. Thank you, sir.
Okay. By substituting 0.08. Hello.
Sorry, the previous board.
Okay, for x in, let me just finish this. 1 plus x power half and its expansion. Find root 3 correct to 4 significant figures. Previous bonds. It's here.
Okay, sir. Thank you.
So by substituting 0.08 for x in 1 plus x to the power half and its the expansion, find root 3 correct to 4 significant figures. Solution. You start with the expansion. 1 plus x to the power half is the same as 1 plus half, which is our n, multiplied by x plus half, our n, half minus 1 over 2 x squared plus half, half minus 1, half minus 2 over 3 factorial x power 3. But this is the same as 1 plus half x plus half, half minus 1 is negative half, over 2 is the same as saying multiplied by half. X squared plus half, half minus 1 is negative half, half minus 2 is negative 3 over 2. Saying over 3 factorial is the same as saying 1 over 3 by 2 x power 3. So I'm saying when you say half divided by 2, it's the same as you're saying half divided by 2 over 1, which is the same as half multiplied by 1 over 2. That's why I've multiplied the half there. So don't get lost. So this is the same as 1 plus half x minus 1 over 8 x squared plus 1 over 16 x power 3. Since 3 here 1, 3 there, 1. So we have 1, 2, 3, 4 twos. So 2 by 2 by 2 by 2, that's 16. So this is the expansion. Remember, and it's the expansion. So by substituting 0.08 in this one, so we substitute in that one where there is x, and in its expansion 0.08, when you add this, you get 1.08 power half, giving us 1 plus 0.04. If you divide 2 into 0.08 minus 1 over 8, when you expand this, 2 decimal places, when you square, they become 4. But 8 by 8 is 64. 1 over 16, 0.123. 8 times 8 times 8, you get 512. Then you 1.08 can also be written as a fraction. 108 over 100, and half is just the same as the square root. This is 1.04. If you add the first two, this one and this one, minus 0.008 in 6, 0, 8 in 64, 8, plus 0.16 in 000, you get 0, 0, 0. 16 in 5, you get 0. 16 in 51, we know 16 goes in 48 3 times and leaves a remainder 3. And in 32, 16 goes there twice. Hello.
Hi.
I'm good. Almost getting things.
Start from the 1 plus 0.08, the power half. Start explaining from there. I'm behind.
1.08 to the power half is here. You just divide 0 here, 0.08 divided by 2. 2 in 0, 0, 2 in 0, 0, 2 in 8, 4. That's where this one is coming from. Then 0.0064 divided by 8. 8 in 0, 0. 0.8 in 0, 0. 8 in 0, 0. 8 in 6, 0. 8 in 64, 8. That's where this is coming from. This one. Then 0.000512 divided by 16. 16 in 0, 0. 16 in 0, 0. 16 in 0, 0. In another 0, 0. 16 in 5, 0. 16 in 51, it goes there 3 times. Remainder 3. 16 in 32, it goes there twice. That's where this one is coming. Now that we have them here, the next thing will be 108, we are looking for root 3 here. So it can only come from where there's a root. This side, that's where the 3 will appear from. So the square root of 100 is known. So we can separate these. So we'll have 108. If we break it by 3, we may by chance find a perfect square root. Let's see a perfect square number. So 3 in 10 goes there 3. Remainder 1, 3 in 18, 6. So we can write 108 as 3 or as 36 by 3. As we separate it from 100, the square root of 100 is 10. Then 1.04 minus 0.0008. So we can put 2 zeros there. We're subtracting. So 4 here, we get a 1 to give to this 0, so it becomes 9. Then we get a 1 from it. It was supposed to become 10. Now I've gotten a 1 from it. Take the other 0. So 10 minus 8, we get 2. And then 9 minus 0, 3 minus 0, then 0.1. So now we have gotten 1.0392 plus 0.000032. The square root of 36 is 6 by root 3. As we multiply, so we add, when you add these two numbers here, you get 1.039232. And then multiply by 10. We cross multiply by this 10 here. So that we get 6 root 3 is equal to, so now we are approximating, we have started putting the dot, 10.39232. Because when you're multiplying by 10, you just move the decimal by 1, place to the right. Then divide by 6. This implies that root 3 is approximately where did we get 108 over 100? From 1.08. You can change any decimal number into a fraction by counting the decimals. You place a 1 where there's a decimal, and all the numbers after you put 0 zeros so that you make the number a fraction. So it is a fraction at that point. That's where it came from. So root 3 is equal to approximately 6 into 10, 1 point. There's a remainder 4. 6 into 43, 7. Remainder 1. 6 into 19, 3. Remainder 1. 6 into 12. It goes there twice. 6 into 3, 0. The question says to 4 significant figures. So we're ending at 1.732. This is an approximation. Just to show you that
Sir,
it's done. Hello.
there's something that happened. Can you just summarize on how you started? It's a long story, sir.
Okay. On the starting, the question says, do the expansion. After you are done expanding, substitute where there is x, substitute 0.08. So we've done the normal expansion 1 plus x to the power half, giving us that expansion here, which is 1 plus half x minus 1 over 8x squared plus 1 over 16x3. And where there is x, we take 0.08.
So I put a correct thing here. I see where you're explaining from.
So where there is x here, we put 0.08. So it becomes 1 plus 0.08, giving us 1.08 to the power half. Where there is x here, we substitute x squared, we substitute x, we substitute. Work on this. This is just a fraction. 0.08 divided by 2, we get 0.04. 0.08 squared. When you square 8, you get 64. When you square the decimals 2, they will become 4. So that's why we have these 2 more. Then here, when you cube the 2 decimals, you have 6 of them. But 8 power 3 is 512. Then the other space before the zeros. Then now you divide this number by this one, you get this. And this number here by 16, you get this one here. You must first subtract before you add. So this minus that, we get this, plus this guy, we get this number here. Now what is happening on the left? We are supposed to find root 3. But we have this half here as a power. When half is a power, it's the same as having the square root. The square root of 1.08 is the same as the square root of 108 over 100. If you make this guy a fraction, using that pattern here. After making it a fraction, the square root of 100 is 10. 108 may help us to get a 3 inside the root by breaking it by 3. That's given us 36. The good news is that 36 is a periodic square. So we take advantage of that. Root 36 by 3 and take away 36 out of the root. It will come out as 6. You find the 10, which is the root of 100, has been multiplied already on the right. So we have this number here. You get after adding here, multiplied by 10. The decimal move by 1 point to the right. So you have this. Then divide by 6 so that the root 3 can remain alone. When you stop putting dot dots, you put an approximation symbol there. Approximating, divide by 6, so root 3 approximately is when you divide 6 into this number, you get this guy here. You want 4 significant figures, so you get this one here. To show that we are done, we have this one here. Hence, done.
Sir, you said something about squaring the decimals, the decimal point. But when you square a decimal point, what do you mean?
No,
squaring the decimal?
so there we're just taking care of, we're taking care of the decimal places. If you have 0.08, when you square, you know that your answer will have 4 decimal places because you're multiplying 0.08 by 0.08. So whenever you're multiplying such numbers, you add the decimal. So 1, 2 plus 1, 2, you get 4 decimal places altogether. That's what I meant by squaring the decimal. That is the rule of decimal numbers.
You count the number at 1, 2. You count the decimal places twice.
Yes, you count the decimal places and add.
Okay.
So if you have 0.04 multiplied by 0.003, your answer will have how many decimal places? If you are
5.
multiplying.
It will have 5. You count, sir. 1, 2, 3, 4.
All right. So that's Eh, this is binomial. So far, so good. And that's how it ends.
Sir,
Hello.
there's a 3 at last. Why are we dividing it and then adding the one to the 3? Like since it will be 5 at last. So why can't we add it and then it will be like 1.733?
1.733. No, there will be a 0. 6 into 3 is 0.
Sir. Oh, that's how it ended.
Because the next one will be 6 into 32, 5. But there's a 0 before 5. Hello? That's how we end binomial. We are starting on Tuesday, we are starting trigonometry. We'll finish it on Saturday. Because I want to ask this session to be fixed. But we have 5 hours.
Sir,
Hello?
there was a question I saw in one of the spreadsheets. It was saying find the independent tail. Now, how do you find that?
Sir, can we end binomial by answering that binomial question?